Goeiedag mensen, good day people. I must have put it like this. Okay, this is about the XD2 motor. It's a 2304 cc. It's just with a standard bore, 94 millimeter bore, and the stroke is 83 millimeters. It uses the same crankshaft as the XD490 motor. So what I figured out here was with this bore, the cylinder capacity is 576,232 cc. That's per cylinder. Times 4, you get this 2 liter, 2.3 liters. Then you bore it out to 0.6 millimeters. That's oversized. Then you get capacity per cylinder of 583,611 cc. Then the cc rises a little bit. It's not that much. Okay, so if you rebore it to 0.6 millimeters, then you get the cylinder, one cylinder cc of 583,611 cc. That's 2.3 liters, a little bit more, as you can see. And if you rebore it more to 95 millimeters of 40 thou, then it's the same as my pickup, my white pickup's motor. That one is drilled out to 1 millimeter oversize. Then you end up with a capacity of 588,557 cc per cylinder. That's 2.354 cc. Now when it's standard with a 94 millimeter bore, with this capacity, the compression ratio is 22.2 to 1. That means the combustion chamber and the space above the piston will be then 25,956 cc. Now on the oversize of 0.6 millimeters and the engine capacity of the one cylinder or the motor combined will be then whatever 22,484 to 1 ratio. So you can see it's a compression ratio rises as you drill it out to bigger capacity. The 94 millimeter oversize, 1 millimeter, 40 thou oversize with an engine of 2,354 cc, you will have a compression ratio of 22,675 to 1. So you can add the little bit more fuel to the mixture, and then you will have more power. So you can adjust the injector pump a little richer, and then it will perform better with these bigger sized pistons, only 1 millimeter bigger. Anyway, that is about the XD2 motor and its compression. The XD3 motor is a 2,5 liter, and let's get to the story here. It has a ratio of 23 to 1, and cylinder capacity is 624,830 cc. Yeah, cc, that milliliters. Now, okay, let's say this motor came out with a number 3 gasket, the BP5900 there. It's a 1,63 millimeters thick, and you have the piston height of 0,84 millimeters. My 505, when I bought it, it came out of a second-hand car, and the sump had a hole in it, so the engine ran without oil, so I had to do the motor up, just to rear the hele motor, want die gat in die oliebak, die olie uitgeloop, en dit het die laar seer gemaak, en toe het ek sommer die hele motor opgelaat. So they sleeved that block to stand it again, and they skinned the block, and I also afterwards filed the block. As you know, the video of the 505 where I filed the block, that's why the piston protrusion height is now 1 millimeters. That is the height of the piston now, above the cylinder block. So when standard, we say it was halfway between the specifications of the number 3 gasket, and that's 0,79 to 0,89, and we make it 0,84 millimeters. So then, with a gasket thickness of 1,63, that's number 3 gasket, BP 900, with a pan mark, make, then you have a space between the piston and the cylinder head of 0,79 millimeters. Now, the size between here, this gasket is an old gasket, so that's why I must take an old gasket, and this here, the diameter is 95,5 millimeters. So let's go with a 95.5 millimeters, and we get with the standard, with the standard motor, as it came from the factory, as we said, with a protrusion height of 0.84 millimeters and a space of 0.97 millimeters between the cylinder head and the piston head, TDC, at TDC. Then we end up with 5.661 cc in that space. Now let's see what have I done here. This 27 cc. Okay, that is it. The 27.166 cc. That is the total space. That's now the total space of the chamber, the combustion chamber there, and the space above the piston, and the space in there where the valves. That's all together 27.166 cc. That is the 1 and the 23 compression ratio, 23 to 1 compression ratio. So 23 is the cylinder capacity of the piston moving from the bottom to the top. It's 624.830 cc times 4, then you should get the total of 2,499 cc. Okay, then we get to the okay, then I must subtract the space above the cylinder head and the head, which is 5.661 cc from the 27 total space there. Then we end up with 21.505 cc. Now this is the space of the valve, the space under the valves there, because the valves aren't level with the cylinder head, it's a little bit in, and the chamber. That's all makes out the 21.505 cc. With my engine, the piston is now 1 millimeter above the cylinder block at TDC, and I use number 2 gasket, PP 890, which is 1.53 millimeters. Now that is the capacity of the space of the gasket. Where did I get this from? Yeah, there. That's the diameter of the gasket inside, and that's a 22/7 pi, and that is the gasket thickness of 0.53 millimeters, and I get 3,797 cc. Okay, now I put that cc with the 21 of that space underneath the valve and the chamber. We add it together and we get 25,302 cc, and that is now the space between this piston plus the space in the valve and the chamber together. As you can see, it's now smaller than the original size, with a thicker gasket and a piston which isn't as high as that. Okay, so then if you divide this smaller capacity into the cylinder capacity, you end up with a total of 24,694 to 1 compression ratio, and that is why my motor goes better now. It's because this compression ratio is now higher than it should be. Excuse me. It must be 23:1. According to the specifications in this book, then the distance of the piston head above the block mating surface, that is the protrusion height, on the XDP 490 motor must be between 0.35 to 0.70 millimeters. On the XD3 motors, the height of the piston is 0.50 to 0.92 millimeters. The space between the piston and the cylinder head on the XDP 490, for the people with the boat motors, the boat motors, this 0.55 and tot 1.05 millimeter. So the piston can have a space between the cylinder head of 0.55 and 1.05 millimeter. On the XD3 motor, they say 0.58 and 0.98 millimeters. I say a minimum of 0.5 millimeters. Mustn't be closer. The piston mustn't be closer to the head than 0.5 millimeters. That's a bare minimum, I would say. You can go on my, as I made this video of my calculation here. My space is now 0.53 3 millimeters. So I'm still okay with that. So now they say here those cracks there in the chamber won't affect the operation of the motor, but they do when you start it in the morning when it's cold. It misfires and it smokes a bit. So with this compression ratio of that now, instead of there's a 23/1 met 'n 24,694/1 kan ek daai cancel and I cancel this story out of the misfire. I just wanted to look at the valve stories here. Okay, then I'm right. It's 1,15 millimeter between the cylinder head and the valve at the maximum, and at the minimum it's 0.75 millimeters. Okay, so I would rather stick to the 0.75 millimeters. I think that's standard. It's if it wears a little bit out the valve, it goes deeper, and it might end up like this deep into the seat. So if it exceeds that, then you must replace the valves. And maybe the seats too, but firstly the valves. They wear down on the sides there, and they sink deeper into the valve seat. And then you have a loss of compression like that. Okay, so this is for the XD3 motor and the XD2 motor. Compression and cylinder head torque, I say again. I don't go according to the degrees and stuff here. I torque it according to Newton meters. You can do these steps here, but I torque it 80 Newton meters to 85 Newton meters. That's 59 to 63.5 pound-feet. That's the maximum torque. Okay, so I go now I'm gonna go. I say bye-bye. Say tot ziens. Dan sê ek tot ziens, and then I say bye-bye from this video. Tot de volgende keer. Until the next time. Thank you for looking at the previous videos. Or looking at this video too. Dankie dat julle na deze video gekyk het en vorige video's gekyk het. Tot volgende keer. Tot ziens.